Today we're going to talk about generating a fricative continuum because 5 out of 6 phoneticians agree that this would be a pretty cool thing to do. But when you think about it, 5 out of 6 phoneticians don't even have fricatives in their name. So, Alicia, you win the prize for having a fricative in your name. Wait, what were we talking about? Oh, okay, so we have this really complicated procedure for creating a fricative, and I'm going to walk you through this step by step. Let's start with just some white noise. This is just a cartoon of this, and what we're going to do with this noise in the frequency domain is low-pass filter it and high-pass filter it so that a central frequency stands out above all the rest. We're going to change the amplitude of that so that it's a specific decibel level above some other anchor, and that anchor is just another fricative that we did the same process to. Let's do that one more time. Now we have 3 different fricative peaks. Now it's not really a fricative yet, it's just a filtered noise peak. So what we want to do is combine them all together, and now we have a complex sound that has 3 different frequency peaks that each have their own relative intensity to each other. Unfortunately, the amplitude envelope of this sound is still the same as the original white noise, which is to say it's just flat, and that's not really what fricatives sound like. So what we're going to do is apply an envelope shape to this, and when we multiply those two together, we get something that looks a little bit more like a regular fricative. So in isolation, this might not do you very much. Maybe you want to add a vowel to that. And so, for example, we can take the E from C and splice that out and put it into our synthetic fricative, and now we have a whole syllable, C. So you can add vowels from a man's voice, from a woman's voice, from a child's voice, from any kind of voice. But essentially what we're doing here is pre-appending a fricative to a vowel, because the fricative comes before the vowel. We could alternatively put the fricative after the vowel and just append it to it. We could also just create a fricative in isolation with no vowel at all. But if we're doing that, we might as well change up the fricatives, create a whole continuum of them that change by some parameter, like the spectral properties, the relative intensity, the onset envelope or the offset envelope. We can change a lot of different parameters, and the point of this video is to walk you through a Praat script where you can do just that. Okay, so here we are in Praat, and I've selected in my object window a vowel that's just my production of oo. Okay, and what I want to do is pre-append a fricative that ranges from sh to s, so I can create a continuum between shu and su. I have this script here, and the link to the script will be in the description of this video. I'm going to run this, and the first thing you see is this pop-up window that has a lot of different parameters on it. So the first thing I'm going to do is just run this script so you can see what happens, and then we'll get into some of these details. It created a continuum, and now it's asking me to select all the vowels I want to add at the end of this continuum. So I'm just going to add that first sound. And what it's done for me is drawn on the spectrum from blue to red the spectral shapes of the different fricatives in this continuum. And as you can see, the blue one has the highest peak at the lowest frequency, and then the red one has a higher peak at higher frequencies. So what we want to do in the object window is select all of these sounds that it produced. I'm going to go to Combine, Concatenate Recoverably, and then the chain and the text grid are both selected. I'm going to hit View and Edit, and now I can play with this continuum and just make sure that the sound came out the way I was hoping. So I'm going to play the first sound here,
Shu.
and the last sound,
Su.
and they sound pretty good. Now we can listen to them all together as one chain.
Shu, 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 shu.
Okay, so that sounded pretty good. I definitely have a clear sh and a s at the endpoints. So let's dig into the script a little bit and figure out what's going on to produce these changes in the spectrum and how we might make decisions about what parameters we want to change, what kind of continuum we should make, and how we should adjust the script to handling different voices. Let's run the script anew for the first time again. And now you can see starting from the top here, I can select how many steps I want in the continuum. The left side represents one extreme endpoint, and I consider this to be the lower end. So for example, this would be the sh end, and then the right-hand columns are what I consider to be the upper end, or the S end. So for the sh fricative center frequency peaks, I have 2300, 3100, and 5100 hertz. And then for the S end, I have 3700, 5100, 6700. So these are just clean numbers just so you can see that the frequencies are indeed moving up through the continuum. And interpolating, for example, means that the third peak, the highest peak, will transition between 5100 and 6700 throughout the continuum. And this drop-down menu here lets us choose between linear interpolation, logarithmic interpolation, which is really a pretty good approximation of the auditory system, the Greenwood function, which approximates the actual placement of the frequency on the basilar membrane in the inner ear, and the Bark scale, which is a psychoacoustic frequency scale that's used to approximate auditory scaling as well. So any of these last three would be pretty good for approximating auditory equivalence between continuum steps, whereas linear interpolation could be used for another purpose, but not for auditory scaling. The next three rows here refer to the bandwidth of the fricatives. So bandwidth means starting from the center, how much of a roll-off do we get, or how sharp is that peak? So the higher the number, the sharper the peak. So 36 is not that sharp of a peak, and then 56 would be a sharper peak. So this first frequency peak in the spectrum is getting sharper as we go through the continuum. The next set of rows here are the relative amplitudes of the peak. So 5 means that the first peak will be 5 decibels higher than the center peak, and minus 13 means that the first peak will be 13 decibels lower than the central peak. So the central peak, the second one, will be the anchor against which all the other ones are compared. Duration is the duration of the fricative in milliseconds. The rise time means the amplitude envelope starting from 0 energy rising up to full energy will take about 150 milliseconds. And pinching back down to the end, we have 40 milliseconds from full energy down to 0. The intensity we can control here. Okay, and so let's take a look at what these features look like when we create the fricative. I'm going to run the script again. I'm going to select that same vowel, but this time let's look at a single product of the continuum. So here's our fricative. It's 200 milliseconds as we hoped, okay? And so the first 150 milliseconds or so, as you can see, if we look on the envelope, we're tapering upwards, and then the last 40 milliseconds we're tapering downwards. So that's what that refers to there. If we create a spectrum of this fricative, what we can see is that the first peak, which is around 2500 or so, is more intense than the subsequent peaks. And so that's really where we get our relative amplitude. As you can see on the spectrogram here, we're changing the center frequencies of the peaks and the relative amplitudes. And so there are some good reasons to criticize this and say, well, maybe we just want to change the frequencies or just change the relative amplitudes, depending on what auditory process we really want to be exploring. Now suppose I want to run the script and only change the frequencies of those peaks. What I have here is a transition between sh that has frequency peaks at 2800, 3500, 5500, and they transition upward to higher numbers. But what I'm doing with the rest of the parameters is keeping them all the same. The bandwidth stays at 48, stays at 36, stays at 48 for the 3 peaks, and the relative amplitudes I'm keeping all the same. And so when I run this script and select that same vowel, what we can see in the output spectrum here is that we basically just get a shift horizontally across the spectrum. So if we listen to the output by concatenating recoverably and viewing this, we might still get a perception that ranges between shu and su.
Shu, 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 shu.
Alternatively, we might want to run the script by not changing any of the frequency peaks, but instead just changing the relative amplitudes of those peaks. What that looks like on the spectrum looks like this. So now we can see that the center peaks, or the frequencies of these peaks, don't move in the frequency domain, but they're just moving in the intensity domain. So the first peak gets lower, and the third peak gets higher as we transition from sh to sa. And what does this sound like? We can select the continuum, concatenate it recoverably, and then take a listen.
Shoo, 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 shoo.
So our endpoints sound like this.
Shoo, shoo.
And as you can see, both of those parameters can be used. Either the frequency of the peaks or the relative amplitudes of the peaks. Both can be used to transition a fricative from a sh to a s. Now suppose we want to change it up a little bit, and this time run the script not to make a continuum between me saying shoo and me saying sue, but to take Lindsay's voice and have her transition between saying shell and sell. I'm going to take the same script that I just wrote, changing the relative amplitudes. This time when it creates the continuum steps, it does the same thing, but this time when I select the vowel, I'm going to select her vowel, and we can listen to the output.
Shell, 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 shell.
So to my ears, this doesn't sound extremely natural because the frequency peaks in the fricative don't really make sense for her voice. They made more sense for my own voice. So what I need to do is actually change the parameters of the script so that these frequencies are really more appropriate for her voice. So how do I determine what frequencies are appropriate for her voice? I could just play around and take a guess until it sounds right, but if I have a recording of her saying one of these sounds, I can use that. So here I have a recording of her saying this.
Mesh.
So this sh sound at the end, what I want to do is highlight that, get a spectral slice, and then estimate where some relevant frequency peaks might be. So for example, down here, we have the first, large, intensity peak around 3,000 hertz or so. We have another one close to 6,000 and another one around here. It's a little bit hard to detect because this is all just one sloping fricative, but somewhere higher toward the 8,000 range. So if we call up our script, here I have just numbers that are a little higher than before. So I'm starting with 3,000, then 6,000, and then a little bit below 8,000. I'm going to keep those numbers the same, and what I'm going to do is change the relative amplitudes. Because again, if we look at this spectrum, we can get a sense of the amplitude here. It's about 27. This one's a little bit lower. Down here, this is a little bit lower than that. So I can use this spectrum as a guide to see how much the intensity should drop off across the continuum. So with this set of parameters, I'm going to let it run, and I'm going to select her vowel again. We can see the output spectrum just as before. And now when I select the continuum and listen to it, it might sound a little bit better.
Shell, 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 shell.
So I certainly think that the endpoints sound pretty natural.
Shell, shell.
Now suppose we want to do something a little different and not put the fricative before the vowel, but this time put it after the vowel. We have to change some of these settings. Specifically, we have to change it from putting the fricative at the beginning to putting it at the end. But there are some other things we want to change as well. For example, the fricative is going to be a little bit longer at the end of the word. So I'm going to change this from 200 to 250 milliseconds. And this time, it's not going to spend a whole lot of time rising up to full volume. That'll be more time spending ramping down to volume. So I'm going to switch these numbers. I'm going to make it 40 at the onset, 150 at the offset for both ends of the continuum. And at the end of the word, I expect the fricative to be a little bit softer in volume, so I'm going to change this by 6 dB, reducing it down to 64. Now when I make this continuum and select a word, this time I'm going to not select L because I'm going to put the fricative at the end. I'm going to select her saying meh. Now the fricative acoustic properties itself are not really going to change in the spectral domain because I don't really change those. But instead, when we see the output of this script, we hear at one endpoint
Mesh,
and the other endpoint.
mesh,
And if we hear the whole continuum,
mesh, 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 mesh.
sounds pretty good. And if we want to inspect this a little bit, what I'm going to do is make sure our spectrogram settings this time go up to 10,000. And now what we can see in the spectrogram is that on the esh end, we have this pretty prominent spectral peak, this energy down here, which as you follow it across the whole continuum, really starts to disappear at the S end. But the S end has this prominent peak higher in the spectrum, which if we follow it back, gets a little bit softer as we go toward the esh end. And this really is just a description of what we already saw in the spectrum, where the sh end, represented in blue here, has a really high intensity, low frequency peak, which just gets lower and lower across the continuum. And at the S end, the upper frequency peak toward 8,000 hertz is really gaining prominence. So perhaps you're interested in fricatives other than sh and sa. Maybe you're interested in creating a fricative that ends in f, as in fell. So what we're going to do here is recognize that f and s have a number of features that are different between them, primarily the intensity. So s, which is represented here on the left side of this column, has a much higher intensity. I've entered it as 70, whereas f I've entered at 55 decibels. So that's going to be a primary difference. The other thing is that the bandwidths of f are going to be a lot broader. So I'm going to have these lower numbers which represent a slower dB per octave roll-off. The higher the number, the sharper the sound, which is really more indicative of a sibilant fricative like s or sh or j or z, whereas the non-sibilant fricatives, f, v, th, and the, really have a broad spectrum without much defined peaks. So let's run this script and see what it sounds like. This time, again, I'm going to select L. And so the script should sound like a continuum between cell and fell. And what the spectrum shows us is that the S in blue here has a very prominent high frequency energy which just dissipates and becomes lower, and it should sound more like F. So let's see what it sounds like. I'm going to select the continuum output, concatenate recoverably, view and edit. Let's listen to the endpoints.
Cell. Cell.
Sounds pretty good. Now, one of the things that's tricky about F is that the formant transitions at the vowel are pretty important for your perception of this. And this time I didn't control that. I just took a vowel that was spoken after the word cell. So it's a little surprising that it sounds as good as it does. And if you're really interested in the non-sibilant fricatives, you will want to pay attention to those formant transitions. So let's hear how the whole continuum sounds, all strung together.
Cell, 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 cell.
Okay, let's switch gears a bit, run the script again, but this time change some other settings we haven't really fiddled with so far. So this time what I'm going to do is actually keep the frequency content the same on both sides of the continuum, keep the bandwidths the same, and also keep the relative amplitudes the same. Okay, so you might wonder, does this just mean that we're creating the same sound over and over again? Well, as it stands, yes, but let's change something else here. Let's actually change the duration. We'll have it start at 200, but we'll have it end at only 40. And the rise time, of course, a sound with 40 milliseconds can't have a rise time of 150. Let's make that just go down to 3. And then the fall time, we'll make that go down to 15. So what I've changed here is only the timing information. So we're going from a long fricative to a very short fricative. We're going from having a smooth long rise time to a very quick, almost transient rise time. And the fall time is getting a little bit fast as well there. So let's see what this sounds like. What I'm going to do is add it to my production of OO. And as you can see, which is exactly what we'd expect, between the blue and the red, we really have the same spectral properties across the whole continuum. The reason that these are a little bit different is that every noise on every iteration of the fricative generation is drawn from a random Gaussian noise, so there's going to be a little bit of variety across the continuum. So let's string these together, see what they sound like. The two endpoints sound like this.
Shoe. Shoe.
So that one was pretty short, but what I was going for here, maybe is better at step 6, is the word chew.
Chew. Chew.
So what I've tried to create here is a continuum ranging from a fricative to an affricate. Let's see what it sounds.
Shoe, 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 shoe.
So to recap, what we've done today is use this kind of complicated procedure to change a lot of aspects of a fricative that we might want to use in a continuum for a perceptual experiment for some kind of auditory processing. So we've changed the center frequencies of the prominent peaks in the spectrum. We can shape the amplitude envelope to sound more like a fricative or an affricate. We can also change the relative amplitudes of those peaks, as we see in this diagram over here, as they don't change position on the horizontal frequency axis, but instead change position on the vertical intensity axis. And then we can append or pre-append a vowel, or pre-append the fricative to that vowel, to produce whole syllables. So I hope you find this helpful as you're thinking about how you might want to make your own fricative continuum, whether for use in the perceptual experiment or a classroom demonstration, or just to play around so you get a good intuition for what the acoustic properties of different fricatives might be.